All right, so let's talk about just making a flow for, again, anything you wanted to do. It could be a flight booking flow. What I'm actually going to do is I was just on Airbnb and they have a new design, a new interesting flow for actually booking a place. So the idea is that with Airbnb, we have different entities. So first of all, we have we have the destinations. So, we could say we have destinations, and we also have different types of, let's call them homes. So, a destination, it might have like an ID, and a home might have like an ID, but also it has a destination ID because these homes don't just roam around, they're fixed to a certain destination. And of course, we also have users as well. So a user, they have a name, they have an ID, and this is just keeping things very simple. But this goes to show you that that modeling these three different things can be very simple. You don't have to prescribe to any specific framework or anything like that. And then we also have the sequence diagram where once we make a search, so in the UI, we are actually calling out to, let's just call this the Airbnb search service. And so we are saying find search results for this query. And the query is like where, check in, check out, and number of guests. Again, I'm doing this in plain language. And so the Airbnb search service, will respond with the UI and give us results. And then we will select one. So, this is one of those relationships where the UI is basically talking to itself, where we select a home and then we start talking to, let's just call this the Airbnb API, where we will say that we want to make a booking, and then the Airbnb API will go back to the UI and say, okay, here's the payments information, and then the UI will communicate with the payment processor, etc. And then there's the state diagram. So what's interesting with Airbnb is it actually has a new flow in that top bar. So it's actually pretty cool. If you go to airbnb.com, you select, it's unexpected state, but you select a destination, you search destinations like Chicago, and then it immediately transitions you to check in, check out, and then you add your guests, and then it takes you to a search page. I have no idea what I just searched for, but these houses look really nice. And then it just shows you all of these search results over here. So we can sort of model that flow where first we say starts with destination. When the destination is input, put in the check-in date, then put in the checkout date, then add the number of guests. And then when the user presses search, it'll take us to a search results page. The search results will be loading and eventually show up. The user can click on one of the homes and be taken to a details page. They can go back from the details page back to the search page. So these don't really look like diagrams right now. They're really rough representations of them, but honestly, just doing this is going to be very impactful for just documenting what happens in your application. And so what we could actually do is, for example, I could ask, here we'll just do a new one. I could ask, Claude to say, make this a mermaid diagram. And so what it's going to do is it's going to, create that diagram. And then we could actually copy this and go to something like, I think it's called mermaid.live. And then we could paste that. And so just from that, we have our representation of the different entities in our application. And we could even have it build it out. So same thing with this rough sequence diagram. So create a sequence diagram in Mermaid. And also you could ask it to add things I might have missed. And so it's going to generate that. And then we could just use that, thinking for a bit. But the main purpose of this is that even though you're writing in plain language, having this is going to be very useful for not only your teammates, but also assistive coding tools. And wow, okay, so it does have a very comprehensive, sort of hard to zoom here, but a comprehensive flow of how the different actors interact with each other. So once we have search results, we request home details, the user initiates booking, and that's going to create a booking request. This is probably a lot easier to see in swimlanes.io, but you get the idea. You have diagrams that you could generate just from the plain text that you write. And so that's why my point in all of this is just write this out. It takes a minimum amount of effort, and really you could derive so much from this. So let's do one more. We're going to take this state diagram and make this a mermaid diagram too, because Mermaid also supports state diagrams as well. All right, so it's going to generate that. And now that we actually got it. Now that we have that state diagram, we could visualize it in Mermaid. And it's a bit broken. Let's see if this does anything. Nope, it requires you to sign in. So let me do something different. Okay, make this an XDate machine, just for fun. Let's see what happens. It's actually filling in, context and things like that. And this actually goes to show you too that you can generate these machines and not even use them in your own application, but even use them just for visualization. So if we go back to state.new and we import this, then hopefully, there we go. We have our entire flow documented right here and able to be exported visually. And you saw that it really didn't take much effort to do that. So we're entering the destination. Then, once we input the destination, we're entering the check-in time, then the checkout time, then the number of guests, and then we start searching. So we search for homes. It also handles things like if there's an error, we should handle that error and retry. And then we're viewing the search results, and then we're viewing the home details, and then we go back to the results. All of this information is really important to keep in mind when you're either building your app logic or working on existing legacy apps where you might not be sure, like, okay, how does this flow work? Using these AI-powered coding assistants, or even just going through the UI and documenting it yourself, makes the application logic so much more clear, and it gives you a good foundation for if you need to refactor your code base or you need to add features or fix bugs, you do have that outline. So in the same way that we wouldn't build a house without a blueprint, I would not work on an application without documenting it or modeling it at least at a rough text-only level. So this just shows you how powerful and how easy it is to actually document your application logic. And so I like to have a flows.md file where you basically have all of this documentation. Again, it doesn't need to be a specific format. It just needs to be somewhere where both your teammates and also the LLMs and AI tools that you use can easily read it and understand at a higher level what's going on. So, any questions about that? Okay.
Just a comment in the chat that they can imagine that hooking something like this up alongside Storybook would really help from documentation of components.
Yeah, that's true. And another thing that I really want to emphasize is keeping this inside of your code base has two benefits. First of all, like I talked about, both your teammates and AI-powered coding tools are going to be able to take that as context to better understand your code base. And the second thing is it's version controlled alongside your application. If you're storing it somewhere else like Notion, that becomes a lot more difficult to do. So that's why I like having a flows.md file, just documenting the app logic, or you could shove it into the readme.md, however you and your team prefers. All right, well, let's take a quick 5-minute break if there are no more questions. Get water, go to the bathroom, have coffee, donuts, anything you want.
Since we just took a break, unless you need one, we can just keep going.
Okay, yeah, we could keep going, if that's all good with you.
Yep, yeah, we'll be breaking for lunch right about noon, so you can
at noon.
Keep flowing till that.
All right, cool. And yeah, this works out because we'll go through 2 more lessons. Let me just set up here.
Oh, thanks, John.
All right. When they read me. Okay, so the next 2 lessons, we are going to be working on optimizing state management and really organizing it a lot better. So what I want to start off with are a few principles that I personally believe about state management that really help me shape how I think about managing complex app logic and how state is supposed to update in your application. The first one is that events are the real source of truth. If you think about when you make a deposit or make a withdrawal from a bank, how does it keep track of how much money you have in your bank account, and how is it sure that it doesn't go out of sync? It's not like it's keeping this big, just global object where it's like, okay, this person has this much money in there. Instead, it keeps what they call a ledger, but in our case, we could refer to it as just an array of events. So basically, anything that happens in your application is based on events that change the state over time. So, like with the bank, it's you could have a long ledger where it's like you made this deposit and this withdrawal and this deposit, etc. And when you reduce all of those things, you come up with, like we talked about in the first exercise, that's derived value. So that's why I say events are the source of truth. And that's why it's good to think about things in terms of events, because since they're the source of truth, it doesn't matter what kind of sources your data are coming from or what is updating what. Everything can be considered an event that changes your state. So I remember earlier someone was mentioning that, I think it was you, that you were mentioning that you have multiple places or multiple sources of truth where your data was coming in and updating the TV app. So all of those could be considered an event where the event says something changed and the state will react to that change. And by abstracting things in terms of events, you don't really have to think too deeply about what kind of source it is, what kind of library or API you're working with, because at the end of the day, it's just an event. So I really like events too, because events capture a lot more than states changes. And you're going to see this when we get to that dreaded chained use effect example. Because when we're dealing with use effect, for instance, the way that use effects, just rerun are based on the dependency array. And in the dependency array, we're saying one of these values changed. We don't know which one, but one of them changed. So we're missing a lot of information. We're missing the intent, like what caused the change. We're missing, timing details. And we're missing that log of like, here's all of the things that led up to this change. It's just this data update or this piece of data updated, and good luck finding out where it is. So events are the real source of truth. Whether you're using them explicitly in your apps or not, you could conceptually think that anything that changes in your app is due to some event, whether it's from the user or from some external source, doesn't matter. The second one might be pretty obvious, but the use of pure functions and immutability. So I really like using pure functions for app logic just because pure functions are the easiest thing to test. And it's also the simplest way of representing your app logic in terms of when I'm in this state and this event happened, what is the next state going to be? So again, it doesn't matter whether you're working in Angular, React, Vue, etc. You can represent your core application logic using these pure functions. And you could also represent the way that you derive state as a pure function too. So the core principle of this is really deterministic behavior. You have this pure function that runs deterministically, and given the same input, it's always going to produce the same output. But more so, it's easy to test. So you could take that pure function and write unit tests for it. And pure functions are also composable, and you can do things like memoizing the results of pure functions pretty reliably since everything is self-contained within that function. You know they're deterministic, so you know that if I cache this expensive value, it's always going to be consistent with what the pure function was going to produce. So that's why I say try to keep all of your application logic centralized in pure functions. Not a single pure function, but it could be many pure functions. Another principle that I live by is the idea that you should write code as if the framework or the tool or the library or any of the underlying abstractions are just going to change under you. Now, we've all worked in large code bases before and legacy code bases. We know that this is almost never going to happen, whether we, want to or not. But the idea is that we want to avoid tightly coupling business logic to framework-specific patterns. And this goes hand in hand with pure functions for app logic. We want to separate our logic so that it's easy to test and it's easy to adapt pretty much anywhere. Then, of course, there are state machines for modeling, which combines the idea of events being the real source of truth for states, and also using pure functions to represent app logic. Now, again, I'm not saying use state machines everywhere, but thinking about your app in terms of these states can allow you to prevent impossible states and impossible transitions. By an impossible state, I mean, for example, let's say you have an is success and is error. You probably don't want those two things to be true at the same time, but if they're both floating around as use states, then it is very possible that that can be the case. Another one that I see very, very commonly, and you probably have seen before too, especially with limited internet connection, is you might click on a user or click on some search results and you will get a flash of no search results found or this user does not exist, and then 1 second later they pop up magically. And so that's why thinking of state machines really eliminates those kinds of problems where, listen, all of your tests and all of your end-to-end tests are probably going to pass and the user might not notice, but it's those things that really help you make your app more maintainable and more predictable, not only for the developer, but for the user, because we don't want to see inconsistent states. We don't want to see an error that immediately disappears, or we don't want to, run into a state where we can't get out of, such as an error state that requires us to restart the entire application. So using state machines for modeling, which like we looked at the last exercise, modeling states, events, and transitions, are going to be really helpful for avoiding these kinds of invalid states, invalid transitions, and other things that we'll run into when we don't explicitly model our app logic. And then the last one, which we're going to be talking about probably at the end of the workshop, is declarative side effects. And so the main principle of this is we want to separate updating our state so that that pure application logic from the actual execution of the side effects. And so a great example of this is the Elm architecture, where with Elm, you have this idea of when you're in a state and you have some sort of action or event, it's not just going to return the next state, but it's going to return the next state and also what it calls commands or effects that are supposed to run when that state is executed. And so by declaring, or by having that be declarative, we could both easily test that these side effects are going to occur, and also we separate the pure logic, so the pure function, from the execution of the side effect, so it makes it a lot easier to test. We don't actually have to test that, oh, this side effect did something when we ran this function, so let's make sure that it did the right thing. We could just test ahead of time, like, this effect is going to be called. And also, it just makes the behavior more predictable. For example, let's say that we're in a flight search page and we start searching. We don't just want to go to a flight search results page. We want to go to a flight search results page and kick off the searching process. And so that's where declarative side effects really come in handy. So in this exercise, we're going to be keeping those principles in mind through pretty much the entire workshop and, of course, also this exercise. But we're also going to be doing two things. We're going to be, sorry, 1 minute. We're going to be combining states, so really reducing the number of use states that we have. And we're also going to be learning about type states and finite states. So let's talk about the first concept. Let's go to a scratch pad. So finite scratch. Okay, let's say that we have an application for, I don't know, let's say that we're making coffee. So we have coffee type, set coffee type. We have different types, and it's already like just giving me a whole bunch of different options. We also have size, and we also might have sugar and milk. The thing is that all of these are actually related. So, we're ordering a coffee. We do have multiple use states here. One of the things that I want you to get used to, you don't necessarily need to do this, but honestly, when you have a lot of use states, it can become a problem. But group related data together. So instead of all of this, we could just have, let's call this coffee, set coffee. And instead, we could combine all of this into a single object. So this is going to be the type of coffee, the size, the sugar and milk, and we can all have this in one single object. Now, the pattern for updating the state is actually going to be a little bit different. So over here, when we're handling the coffee type change, we're no longer just setting the single state variable. Instead, we're updating the entire object. So that can look like one of two things. It can either look like something where you take that existing object, like coffee, and then you pass in the type over here. So you're basically taking that entire object and just saying, I want this object with this type updated. Now, there actually might be a small problem with this. This coffee is a closed-in variable. So we have a closure issue, which sometimes it's not a problem, but other times, we might see some unwanted side effects, which is why I actually recommend using the pattern of grabbing the previous value and instead using that. So that's going to use the existing coffee over here and say, I want to update the type based on the previous value of it. So that is one way that we could basically combine our entire state. So let's put some default values here, and that's exactly what it looks like. Now, another thing that I really want to demonstrate here, and what we're going to be using in this exercise, is the idea of finite states. So let's say that we have another 2, and then we are making our coffee order. So let's say that we have const coffee order, set coffee order, and this is just some use state over here. We're ordering a cappuccino, and we also want to model actually making this order. So this is probably muscle memory to a lot of React developers, but you're going to start with your const is loading, set is loading, and then maybe const is success. So you have that Boolean, and then const error, set error, and then you're going to actually kick off the ordering process, probably in a use effect. So you're going to have a use effect over here, and then again, this is all muscle memory. You want your coffee order over here, and then it's going to do something. It's going to make a fetch request. So let's actually do a demo fetch request over here. So mock fetch call. So we might do something where we're fetching that order, and then we have all of this boilerplate that we have to add. We set success to true, loading to false, and then we, if we have an error, then we also set loading to false. And this just gets problematic because it might seem simple over here, but we're really managing 2 seemingly unrelated pieces of state that are actually supposed to be related. And we also need to handle canceling. So if canceled, or if not canceled, then we go ahead with this. So instead of that, I want you to, just based on our previous exercise, think about the different states that we could be in. And so this actually makes a pretty simple refactor. Instead of is loading, is success, and error, we could do const status, and we could have a string enum representing the status. Now we could eliminate basically both of these, and instead we could set status loading. We could eliminate both of these and just set status to success, because those are mutually exclusive. We never want it to be loading and success at the same time. In reality, we're just changing one thing. And then we have an error over here, so we're going to set the status to error. And so that's one way that we could really simplify, handling multiple Boolean states that are really meant to represent one kind of state. Now, if you want to go above and beyond, there's a pattern called type states. And so with type states, here's a problem that it solves first of all. Let's say that we're trying to render something, and we have if status is success. So let me add another variable here. We have const receipt, set receipt, and this could either be a string or null. So I want to show the receipt, but again, the receipts. Actually, let's do this. Let's make the receipt like total. We want to show the receipt.total. Yes.
Just a second, since this siren is right up on us. Sirens aren't great, and then you can just pick up with, we want to show the receipt total.
Yeah.
I think that's going away. All right, that's probably good. You can pick back up.
All right. So a problem with this is that it doesn't matter if you're using finite states or if you're just doing something in your application where you are 100,000% sure that this receipt, when the status is success, or even if you have is success, that receipt is going to exist because let's say that we set the receipt over here. So we're setting the status and we're setting the receipt. You know that that exists. So in TypeScript, you might add an exclamation mark. It's actually totally fine if you add multiple exclamation marks in some cases. I discovered that randomly. But the idea is that you want to, at a type level, ensure that this receipt exists. So how exactly can we do that? Well, we can use type states. So type, let's see, coffee order. And we're going to be using in TypeScript what's called a discriminated union. So instead of just a plain status string, we're going to put it inside of this object. So we're going to say status is idle, or loading, or success, or error. And this is actually a good way to start out. You have the error, and then you have the receipts inside the same object. So from there, you could actually transform this to a discriminated union by adding this pipe, and then saying status success. So now we could actually get rid of this, and we could say that the receipt is definitely defined over here. So we could say that in this case, the receipt is null, but when we have success, we definitely have the receipt. And so here's how this looks. Let's actually just put this somewhere else. So let's const coffee order, and then we have idle. We have no error and no receipts. And I'm actually going to delete this over here. And so instead of this, we could set coffee order to status success with the receipt. And here is the really, really cool part about this. This enforces the data in two places, both when you're setting it. So if I get rid of receipt, it's actually going to yell at me and say, you're missing the receipt here. You're saying it's success, but the receipt doesn't exist. So it's really forcing us to keep that state consistent. And then over here, I no longer need this, or I have to do coffee order.receipt.total. So if I'd say coffee order.status is success, then I know for a fact that that exists. So if I change this to error, I know that we don't have a receipt here, or at least we can't read the total, because it might possibly be null. And so that's what type states are very, very useful for. All right, any questions before we move on to the exercise?
Are there any ESLint rules that could help point out some of these things, like using the previous?
As far as ESLint rules, I'm not sure if there are any specifically. I will say that there do exist ESLint rules for when you do this. So when you have this type assertion operator where you're saying this definitely exists, there might be an ESLint rule that says, hey, you probably shouldn't use that. You probably should just be very, very certain that that exists, first of all. But as far as using type states, I doubt that there is an ESLint rule for that.
In the first example, when setting the coffee state, you mentioned using previous because splatting coffee had some pitfalls. Which, by the way, I think this is the answer to the previous chat's question about setting a profile, setting the name and profile. This is what he was wondering. They were wondering how to do this. But what are the pitfalls of just spreading coffee versus using the previous state?
You might run into closure problems with that because you might have a stale version of coffee. No one likes stale coffee, especially if you microwave it, it tastes terrible. But if you have a stale version of a value, then when you set coffee, you might accidentally revert to that previous version, or at least different properties of that previous version. And this can show up in many cases, like if you put this in a use memo and decide to memoize it excessively, or maybe it's in an event handler that does not change for some reason, or even in a use effect. There's just many places where that might come up. And so that's why, honestly, as a best practice and a habit, just try to go based on the previous value inside of that function, because over here, you're guaranteed that that value is going to be the latest value of that state.
And could combining states like this into one object make or lead to unnecessary re-renders? I'm thinking of a scenario where related state to be updated in a I'm thinking of a scenario where some related states will be updated in one context provider, but a smaller consumer component may only use one part of the data. So will that lead to unnecessary re-renders?
That's a very good question. So it definitely depends, and this would be a good use case for use memo. So you could just see if all of those values are the same. But honestly, it's not a big problem in practice. I wouldn't recommend you to just put every single use state inside your component inside of a single use state. Instead, I want you to separate it by concern. So, for example, this coffee object, this is an object that we could pass around. And so chances are that if we change the size or any part about that coffee, the entire object fundamentally changes. And so we might want to let components downstream know about that change. But in practice, I haven't seen this to be a problem. So always just double check before you decide to put any optimizations in place. But just know that there do exist optimizations in React, like use memo, etc., for for that. And then Masiaj asks, in coffee order, did we use generic type as the first variance because the union was not exhaustive? So in reality, this, you might want to flesh this out a little bit more. So for example, if we're loading, then we know that we don't have a receipt, we don't have an error, but if there's an error, so we definitely have an error and there's no receipt. So then we could just get rid of these, and we have our complete type state over here. So this is more around the lines of what it should look like. All right, any other questions? Great, so we are going to jump into the next exercise. And so what we're going to be doing is two things. First, we have a flight booking form. We're going to be combining related state variables. And this is just, again, to practice getting used to combining related state into one single use state. And also, because there is some loading and error and success states, we also want to remove the Boolean flags and create finite states instead. And you could start by just having a simple status as a string enum. Or if you want to, again, go above and beyond, you can use discriminated unions and use those type states. So I'll give you a few minutes to do that, and then we'll get back to it.
Sounds good. back.
All right, so let's clean this up a little bit with some finite states and combining things. Another thing that I really want to talk about too is the Strangler Fig pattern. And this is actually going to help us solve this exercise because likely you don't want to just delete code and replace code and then pray that it works. Instead, you really want to check side by side if the code that you're replacing the previous code with is going to be the correct result. So we could combine pretty much all of these, like the destination, departure, arrival, and passengers together, and we could combine it into one. Let's call this flight data, and actually it's not going to be that. Let's turn off this. So this is going to be the destination, departure, arrival, and passengers. And so this is going to be the default states over here. So we have empty string, empty string, empty string, and passengers. We'll just default it to 1. And so again, we are going to identify these Boolean variables which are actually mutually exclusive, and we're going to change this and put it into a status. So const status, set status. We're going to use state. And so we could start off with saying that, maybe it's idle. We didn't do anything yet. But we could change this to a string type, or what I like to call a string enum, or at least it functions like when it's not literally a string enum. So idle, submitting, error, and success. And so what this allows us to do is we could actually just side by side work on refactoring this while just maintaining the same structure that we have. So for example, when we set the destination, instead of this, we could just set the flight data to, again, we're using previous. So we are going to get the previous data and set the destination to e.target.value. And so we could do this for the other ones too, just to make sure that everything works. So I'm going to do this for that. And again, this is the exact same thing that we're doing. We're taking the previous data and we're just updating that one field over there. And same thing over here. Another quick trick, you see that we're doing parsins over here. What we could actually do is e.target.value as number. And that basically does the exact same thing. So then when we have things like is submitting, we could do one of two things here. We could either keep the same variable, or we could have a more explicit like flight data dots. We don't have the status, so we could say status is submitting, or like we learned about in our first exercise, and this is actually a really good way to not change too much code but still do the refactor that you want to do. We could keep that is submitting, and instead we could derive that data. So we have our status over here. We could say const is submitting is basically if the status is submitting. So these Boolean flags become something that's derived rather than something that becomes a source of truth. So again, that first exercise is really showing us how we could improve the way that we model these things. So now if I get rid of this, we see a bunch of variables together over here. And so instead of all of that, we could just set the status to submitting and then get rid of the other ones. And then we'll set the selected flights to null. This is also a good indication that if you want to, you could use type states to really combine that into a single cohesive state variable. So instead of set success true, we could set the status to success, and then over here we could set the status to an error. So now you're going to see that, again, lots of red here. We're no longer using this. So we could do things like derive more data. So we could say destination is flight data.destination. And in fact, we could just pull out departure, arrival, and passengers from here. And that way, we have limited changes to our code, but we can reduce the number of use states that we have, and we could have all related data in a single object. So, just going through this again, we no longer need things like set is error true because now we're setting the status to an error. And so same thing over here, is error and is success. You could either change that to checking the actual status, or you could derive that data. So we could say const is error is if status is equal to error, or const is success is equal to if the status is a success, and then everything should work the exact same. So again, being able to look at your application and understand the different flows that it could be in is really going to help you out here. So in this case, we know that like this can be considered some sort of an idle state, and you might choose a date, and then we have this loading state over here, which we could visually verify, and then we have the state over here where we successfully have data. We could select a flight, and we could see that booking summary. And if we wanted to, this can be a different state on its own, and that is actually going to be the case when we go into future exercises. So, yeah, any questions about this exercise and how we refactored everything?
Not directly related to the exercise, but there was a question about your opinion on using arrow functions within a handler, because isn't passing the function directly to the handler a better approach?
Oh, okay. So the question was about, like, for example, handle flight select. If you could do it here. I honestly, so it sort of doesn't matter to me. It is dependent on your team, though. So some of your team might like to put all of their handlers up in front, and I think that that's a very good way to see everything. Just like that principle we talked about, where we're separating the framework from the actual logic. And so by having the handlers up in here, then you see all of the logic together, and then all of the UI below that. So it is pretty nice to do that. In terms of arrows or functions, that doesn't matter to me either. But yeah, another thing that some people could do is, instead of handle flight select, they might just set selected flights directly over here. And I honestly think that that's fine too. If you find yourself repeating that a lot, that's where a handler might be useful. I think a lot of React developers do go overboard, and they try to memoize that by putting it in a use callback. And honestly, if you don't need it, then it doesn't really matter if you do it or not. I like to only memoize if I notice that there's a problem.
Isn't there some kind of performance overhead associated with use memo and use callback too? Like, so if you're using it when you don't need to, it can actually make things perform worse?
Exactly, yeah. And this is something that you learn in computer science. I only took a couple of classes, but when you're doing optimizations such as caching, memoization, etc., it's not that you're making everything magically faster. You're trading performance for memory. So there are trade-offs there. And so if you try to use memo everywhere, then the internal memory used by the React app will, it might balloon, it might slow things down. Honestly, like, everything's a micro optimization until you actually run into the issues and see that, okay, this is slow, but if I do this, then it's definitely visually faster for the user, especially on a slow connection or low powered computer. So yeah, I like to be pragmatic about performance, basically only when necessary.
I know React 19's goal is to release the compiler in its full state, and so therefore they're attempting to try and minimize the need for use memo and use callback. What's your take or opinion on that shift in their paradigm?
I think that, yeah, the React compiler is great, and this is more reason to use idiomatic React patterns and not try to do anything crazy or try to over-memoize or do callbacks or things like that. I will say that in larger code bases too, first of all, with React compiler, there is that expectation that you're using React and React's hooks as designed. However, I have seen in many code bases, and it's sort of inevitable with larger code bases, that people will have a long dependency array with like 5 or 7 different items inside, and they will be missing maybe 1 or 2 different variables that should be in there, but they'll be missing them on purpose. Because if you add those variables in, then the use effect might run multiple times, or the use memo will unnecessarily call itself again and maybe have a side effect in the use memo, who knows. But the idea is that they will disable the ESLint rule for that dependency array because it's one of those, it works, don't touch it, and if you complete the dependency array with everything required, then it's going to break. And so there's so much of this in existing React applications, and that actually doesn't work well with the React's compiler. So that's why I say try to avoid having too many things in dependency arrays, or even using hooks that require the use of dependency arrays. It's going to make your life simpler, and it's going to make React compiler work a lot better because you're just doing things the most natural way. Any other questions? Oh, can we show the type state implementation with this example too? Okay, yeah. So let's quickly do the type state implementation, and I think it's good. You know, we have 6 minutes. So with the type state implementation, what we want to notice is that we have things like when we're setting status to submitting, we're also setting the selected flights to null, or we're setting flight options when it is a success. And so these are all clues that we could use a type state to really reduce the number of states that we have to set and the states that we have to manage. So we're going to, we have flight data over here. Let's actually add the status inside here as well. So this is going to be idle. And so now we could actually define our type states. So we could have type flight data, which includes all of this. So we have our destination, departure, arrival, and passengers. But we're also going to be adding, with an intersection type, we're going to be adding our different type states that we could be in. So just for speed, I'm using Claude. But we have, for example, idle, submitting, error, and success. So we know in success, we have our flight options defined. And we know that in error, we might have an error message over here, and that when we're idle, our flight options are actually null. And same thing for submitting, our flight options are null, so we don't have those in there. And so this is a pattern that, if you have common data, then you might want to use an intersection type for that. So you would have all of your common properties in one object intersecting with your discriminated union at the bottom. And so that way, we have flight options null. And you could even, in fact, it is good practice to put everything up front here. So we have flight options and we have an error. So we're representing all of the possible values that it could be here, but we're limiting that when we actually deal with each of the type states down here. And so now when we have something, for example, set status submitting, we can instead set the flight data to have the status be submitting, the selected flight be null, and of course the error is going to disappear too. And then we no longer need those variables. So same thing for when we actually have a success, we could reduce these two into a single set flight data with the status of success and the flight options that we have. And so it's yelling at us, if we look at the bottom, flight options are not assignable to null. So that's actually a really good call out. So this is where TypeScript is actually helping us, because flights, actually no, that should work. So I
think in our await, it doesn't know what the type is.
Let's see. So the flights, they're definitely flight options. And so types of flight options are incompatible. Let's debug this together. So we have flight options. And so flight option is not assignable to null. So if we hover over this, it's flight option. If we hover over this, it says that it's null when status is success. So that indicates that there might be something wrong with my actual types. So we have status success, flight options, set. Oh, okay. Wait. Very weird. If I get rid of this, let's see what happens. Is the and at the right place? Let's see. And yeah, it should be. So another way that we could test this type is, like, let's say const f flight data equals, let's say, status success and flight options. Okay, yeah, so that definitely should work there. You know what, I might be missing some other things too. Let's just set all this and see what's wrong. TypeScript can be tricky sometimes. So the types of flight options are incompatible. Status. I see that their status as string. Interesting. So if I add that as const. Yeah, it might be a syntax error too. Probably because of that.
Maybe you need to actually type the use state up there for the set flight data. It's just according to the object you pass in, right? Here.
Oh, you're right. Okay, so we had that type state, but we didn't actually have our different options over there. Okay, so now it works. Thank you. We were just missing the type. That's all. So, okay, wow, that was an embarrassing mistake, but hey, type saved the day over there. So yeah, that's an example of how you could use discriminated unions and type states, and also combine related data to reduce the number of use states, and also just keep your data more consistent. Any questions?
Just James saying TypeScript can be tricky sometimes is the understatement of the century.
It helps you out, but it also can cost a lot of time. But it's more helpful than it is a burden. So I do appreciate it. Then we could have error.
Well, that even caught the fact that we didn't include error there. I mean,
Exactly. So that's what I mean about just keeping your data consistent. And so if we happen to have flight options here, it's going to yell at us and say, wait a minute, this should not be possible. So, okay, any other questions? All right, well, let's break for lunch.
Still
Or-
waiting on the lunch. Looks like it was going to be here. Well, not exactly sure, but sometime in the next 10 minutes. So if you want to start into the next lesson, just to keep making progress, or
Yes. We have a lot to cover, so I'm happy to. Okay, so the next one that I want to talk about is actually it's a shorter lesson, but it is one of the ways that you could actually simplify basic forms. Because let's be honest, a lot of our application is just a bunch of forms. And most of these forms are actually simpler than we realize. So I'm going to go to the Scratchpad here and just demonstrate to you basically what we could do about forms. So let's say that we have a form and we have, first name, set first name. And just for this example, we're going to only use one first name. And then we have a form which handles that first name. This is code that you learn when you are first starting off in React. It is probably the most basic and common example of use state and working with forms. And so the idea is that we would have an onSubmit over here. And again, this is muscle memory, but you would type event.prevent defaults because the form is going to have some sort of default action of reloading the page, and you don't want that, which is why we have that over there. And then let's say that our form just consists of the first name and we want to do something with that. We could just console.log the first name. But here's the thing. In HTML and the DOM, the form actually contains the state itself. So really, we're duplicating state over here. When you type into an input, and especially if you give it a name, like let's say that we give it a name of first name, that data already exists in the form itself. So let me show you what I mean. If we get rid of this onChange, and instead we read the form data from the form, then we could really just, in a way, we could derive that information. So we're going to grab the form data using this new form data constructor, using this target, which is the form element. For some reason, even though we're in onSubmit, TypeScript thinks that it can be any random element. So we have to say, no, this is definitely a form elements that we're working with. And so what you're going to get is a form data object. And so the form data object, it has its own API, but it is completely native and supported in all modern browsers. So what we could do is, if we want to get the first name, there's formdata.get, and then we could get that name, just directly from the form data. And so what this allows us to do is really eliminate a number of use dates, so we don't have to keep track of each individual field. Instead, we could just read from that. Now, if you have many fields, then we could actually use Zod as well. So how many of you are familiar with Zod? Okay, or whatever related library you're using. So with Zod, we could actually parse. We could create a schema for the form, and so we could parse that information from the form. So let's say const form schema equals an object where we have the first name, and then we could just add some validation there. But Zod also allows us to parse and see that the entries of this form data, which the form data you could use object.fromEntries because it's going to be key value, key value, key value, and then you could create an object from that. So you could parse that using the form schema, and if there are errors, and this allows you to do form validation as well. So you might have a first name is required thing or something like that. But we could get parsed data first name, if it exists, and we know that that's going to be a string. So that's how you could use Zod as well in combination with form data. So why am I showing you this? This is definitely an alternative to using just multiple use dates for your form. But also, when you're working with a Next.js application, there actually is a hook that really helps you work natively with forms. There's both a hook and there's a native Next.js server components or server action feature that allows you to pass a server action directly into a form And to use that, and this will handle all of your forms, loading states and, the response from submitting the form and everything like that. So the way we could do that, if I get rid of all of this, we're going to grab the use action state hook. So it's going to be state, some submit action. So just going to say action equals, and this is something that just takes form data. So we're going to use action state, pass that submit action in there, and then also pass in an initial state. And this is just something that that it requires. So this initial state we could just have as null. And it's also going to give us is pending. And so the cool thing about this is that we could pass in that form action directly to the form, and then we don't need to maintain the each of the individual variables because it's going to be done via name. And then when you press submit, it's just going to go through that form action. We're going to get is pending, so we could definitely have a pending state. So if is pending, then we could show something like a loader or something like that. And then eventually we will have our state. So if we have our state, then oops, not that, but we could return the state that we get from the submit action. So for the next exercise, I'm not going to actually have you do this, but we're going to be doing it together. I just want to show you how we could use these native form form tools that we have built into the browser and built into Next.js instead of having to manage a lot of use states with those forms. So I'm going to get rid of that. And then we are going to go to, let's see, exercise form page. And over here, we definitely have a bigger form. So we're going to definitely simplify this a lot. At the very least, we do have our combined data over here. So we have our travel form data. And just to show you what this looks like in the UI, if we go to form, this is a form for entering travel information. And there's a lot of fields in here, which is why I'm showing you this pattern, because doing this with just use dates, it can be tedious. You have to have a use date for first name, last name, birth date, passport, origin city, etc. I feel like 2000's I feel old because 2000, I think, okay, there's kids that are born in 2000, but it's all grown adults. It's very weird. But anyway, you have your passport number there. And the idea behind this is we want to have server-side validation, and that's what you see coming back over here. But in this form, you can also submit your travel data, and then you could submit another form, and then keep going like that. So our initial implementation, we're using useState a lot over here. We have these these Boolean flags: is submitting, is success. Hopefully you immediately recognize that you can change that for a simple status string enum. And same thing over here, you could use type states and discriminated unions to sort of combine the status with the data. But we're going to be simplifying this even further than that. So again, using the stringler fig pattern that I talked about, we're going to start by saying const state submit action, which already exists, and I'll show you in a minute, and is pending. And we're going to be grabbing that from use action states, which is a React hook. Again, you have your submit travel data, and also you're going to be passing in an initial state. And just to show you what this initial state looks like, we have our, we have all of our information here. Oh, this is the, wait a minute. Okay, let me just make sure that we have the right initial state over here. So this is actually going to be coming from somewhere else. Okay. So initial state, form state equals status idle, no errors, and data null. And so you'll see how this is used in a minute. But the idea is that all of our inputs should already, I'm going to go ahead and hide this, but all of our inputs should already have names. And so that's going to be the thing that really powers using form data, is the fact that our inputs and all of our fields have names that are going to be fed into the form data that we derive from it. So instead of on submit, instead we're going to put action, and this action is going to be our form action that we have over here. So just going to the top, submit action. And then what I'm going to do here, instead of deleting everything first, is I'm going to console.log the states, just so you see what we're dealing with. So we have the state over here, and we are also going to console.log is pending over here. All right. So now we're going to, first of all, let's make sure we're running this. All right. So we're in our exercise form. I'm going to open up the console over here. We have is pending as false. We have our initial state object. So let's go ahead and enter some details. Again, the state is changing. And if we submit this, it is going to hit the, even though it's invalid, it's going to hit that server action. And we're going to get some data back from the server. So we're going to see a bunch of errors. We're going to see that the birth date's invalid, the origin city's invalid, etc. But it is hitting that server, and we also get a status back. So where does this happen? Let's take a look at form and then actions. So when we submit travel data, first of all, we're getting this raw data, and we're getting it from the form data that it receives. So we could validate the data using Zod like we talked about, and then we could use that to generate errors. And so if we have errors on like specific pieces of data, then we could pass that back. However, if everything goes well, we sort of have a mock API over here. But if all goes well, we have the success, and we're also returning the data from there. And if we have an error, then we're actually giving back the raw data because we don't want to completely blow away the form states. We want them to be able to, to correct their errors. So in this case, we're not managing the status inside of the actual UI, but instead we're managing it on the server side. So we're saying, the status is success, and in this case, we also have results data. So if we go back here and actually fill everything out, so 2000, not my actual birthday or passport number, and I don't know who would ever pick middle, but it's an option in some airlines. But once you submit this, it's not happening because we didn't update it in the UI, but you could see over here that we have state of success. We have our data coming back, we have no errors, and we can use that in our application. So just like what we did previously, instead of using this is success use state, we could derive that. So const is success equals state.status equals success. Same thing here. Instead of errors, we could say const errors equals state.errors. And same thing over here. Instead of is submitting, we could say const is submitting equals if the state.status is pending. And now we have a bunch of errors, but we could just comment those out because we're actually no longer using this function at all. So we're just going to comment that out. So now, when we fill out our form again, set the birth date, passport number, origin city, seat preference. Oh, Okay. Let's put 2000. Now, let's debug this together. We could see that we have a status of success, but it is not showing us success. Oh, it's if we have success data as well. So that is still in the use state, so we need to derive that too. So const success data equals states dot data. So now, one more try. David K. It's my actual birth date. I love sitting in the aisle. Okay, now we have our successful travel data, and now we could actually get rid of basically a lot of things. We could get rid of all of these use dates and all of this unused code, and you know, even this, like the whole set form data thing, where you know we basically don't need that anymore, so we could get rid of that. And so now all of these can just be uncontrolled components. Oops. And so you could see that this really simplifies how we work with simple forms. And then, yeah, we no longer need this handle submit because everything happens inside of that server action. We no longer need this update form field helper. So update form field, again, where this is going to be just uncontrolled data, so we don't need that either. We're actually going to turn on Claude and have it help us out here. Don't need this, or any of these. So we could get rid of that and get rid of that as well. So now you see that we really simplified our form. This might not even be necessary if you use the state status directly, but everything is just a lot, you know, it's a lot simpler. And in fact, this is pending. This is redundant because we don't need is submitting. We could just, you know, basically have that as is pending. So we have all of this is submitting, which we could change to is pending, and then be all good. And so now there's a lot of unused things that we could remove, and our code just becomes a lot simpler. So that is how we could use the use action state hook and use built-in server actions to handle forms. And also at a basic level, using form data for basic forms where you don't need anything special with a form, you just need to capture data. Any questions on that?
Is it possible to have immediate blur focus, validity checking for those inputs when they are not controlled?
That's a good question. So, two things. First of all, with server actions, it's sort of, or you know, form actions as it's called in React. It assumes that you're going to basically submit your form all at once, so it's not going to be doing any validation on blur. The second thing too is that when you have uncontrolled components and you want to basically keep track of validation errors on blur, I recommend you use some of the patterns that we learned about earlier. So for example, we could do things like let's call these validation errors, set validation errors, and then you know we'll have a use state for that. And this is somewhere where use state is appropriate because this happens not during the client server interaction, but it instead happens only on the client. So what we could do is, let's say that you know we're let's just pick one of these fields. So for example, first name. First of all, if you can use HTML5 validation, then this is something that I strongly recommend you do. So this is, for example, if you add required, or if you add a pattern over here just to make sure that the data is valid. Like this just says it should be more than one character. So basically it's like it has to be there and it has to be a valid name. Then I would recommend you do that. Otherwise, you could just on blur, you have the event.target.value. And so you could say const value equals event.target.value, and then you could do validation directly in there. So you could set the validation errors, for example, if it's less than 3, you have that over there. Just be sure to handle what happens in terms of showing that. So for example, if this is focused, you don't want to necessarily show that error, or maybe you do, and maybe it goes away once you blur from that again. But this is just an example of how you can do validation on blur in an uncontrolled component, because you have that value right there.
Okay, I think lunchtime, we'll do 40 minutes for lunch, and then we'll be back.